Hello everyone, my name is Jules Heiman and the technology that I chose was 3D printing. So here is kind of the overview of STEM broken down within 3D printing. So the first one is science, obviously. So the scientific makeup of 3D printing materials. So it is a 3D printing is made up of different types of materials, plastics, or even ceramics. Each type has unique characteristics that give printed objects specific properties, like if they're strong or if they're able to like bend or be able to be flexible. So what are some of these materials? So 3D printing uses plastic called filament, which is kind of like the hot glue sticks in a hot glue gun. The different plastics equals different strengths, flexibilities, and how they're able to be used, just kind of like I stated above. So here are some of the common examples that I found while researching. So PLA sounds like it's the most common one, and that's made of sugar or corn. It melts easy. It also doesn't smell too bad, and it doesn't warp much as well. The next one is ABS. I'm not even going to try to pronounce those words, but there you have it. It's a tough plastic, kind of like a Lego brick. It can handle heat way better than the first one that I mentioned. It's also strong and very flexible. PETG, there's the actual name there for you. It's similar to like water bottles, so the bendy and flexible material. It's stronger than the PLA. It's also less brittle and it doesn't smell when it's being melted. And then nylon is very tough and bendy. It doesn't break easily. It's good for like moving parts while oh my god, 3D printing, and it acts like a sponge, so it kind of soaks up water. So some chemical properties of the filament. So filament is used for 3D printing, which is basically those types that I just mentioned, and they have distinct chemical properties. So what are filaments made of? Filament is long chains of molecules called polymers. Think like you're cutting up spaghetti and they stick together in those lines. That's kind of what it looks like. Um, these chains have plastics and their melting point strength and bendiness. So PLA, like I said, is the sugar in corn. It's known as the corn plastic. So it's made from lactic acid, normally found in, like I said, corn or sugar. It melts easily, breaks down in compost when it's under the right condition, and it's not great in the heat. ABS is the tough one, so it mixes with different. It's a oh my gosh, copol. I cannot speak. Copolymer, and so that's a mix of different types of plastics. So it's very smelly when it melts, which is not ideal in some cases. Nylon, which is the super tough one, it gains really strong chemical bonds and can bend really without breaking, but it does absorb water, so you have to keep it dry in order for you to print with it, or else it prints very weirdly. Now moving on to the second part, which is technology. So, the manufacturing and the functionality process of the 3D printers. So, building a 3D printer involves assembling parts like a frame, motors, extruders. Each component contributes to how well the printer performs in making sure that the print comes out right. So, the frame is just kind of what holds it all together. The motors are like the moving parts, so like the gears and all the things that move. Extruders are like the things that heat up, so like as you can kind of see over here, it's the thing that's heating it up and spits out the plastic. And then the bed is kind of where your project is being laid, so it's the bottom part. 3D printers work by creating layers of materials based on a digital design that you either created through a file or something on the computer. The process varies depending on the type of printer, and they all aim to bring ideas to life, and they do it one layer at a time. Evolution of 3D printers. So 3D printing has come a long way since the early days. Initially, it was primarily used for prototypes, which is now widely embraced for everything in the medical field, like medical implants, all the things. Technology has improved in speed, accuracy, materials options, making it more accessible and effective. So it kind of started in the 1980s to 90s when it was first invented. This was really only in labs or companies because they were so expensive. Those places could really only afford that. They were mostly used to make like testing parts that weren't real yet. And then moving into the early 2000s, they got a little bit smaller and a little bit cheaper, so that still made it where they were used in car companies and engineering, and the materials were very limited. And then in 2010, they came out with home 3D printers. People started printing like toys, tools, phone cases, just fun things because they were finally able to get their hands on one. And then websites started sharing files that you could download and just print something rather than making your own design. And then today, 3D printing is used for medical stuff like fake bones or custom implants, fashion, and construction. Number 3 is engineering. So, mechanics of 3D printing. The mechanics behind 3D printing involve moving parts that work in perfect harmony. So that means the print head moves precisely to build layers based on the design, and understanding this movement is key to producing high quality parts. So how does it work? You can make or download the 3D file. The printer reads the file and figures out how to lay it layer by layer. It melts plastic and squirts it out onto the base or the bed. It sticks tiny layers to build the object from the bottom up. When it's done, it cools and hardens, and then you're able to take it off, and there's your project. Why does a 3D printer work? It follows the instructions from the 3D file. It melts the material and lays it down one layer at a time. Each layer sticks and it becomes one. Comparative analysis with other technologies. So 3D printing is different from other types of manufacturing because it builds objects layer by layer, while older methods like cutting, molding, or mechanicking usually remove materials or shape it using molds. Compared to the traditional manufacturing, 3D printing is cheaper to start with, better for custom or small batch items, and creates less waste. It's also easier for people to use at home or in the classroom. I would kind of like to have one in my classroom. I think it'd be pretty cool. I had a class in high school that we had 3D printers and it was fun to use. However, it can be slower when large quantities, and sometimes produces larger products aren't strong or smooth, like a CNC machine. We also had one of those, and those were super cool. The CNC machines is better for high precision metal parts or projects. 3D printing is ideal when you need flexibility, creativity, and low cost testing of items. Lastly is the mathematics section of our STEM. So mathematics in 3D printing plays a huge role. It calculates the volume for adjusting material flow rates. These equations help ensure your print comes out just right. 3D printing obviously takes digital models into real life objects by building them one layer at a time. It relies on geometry to understand shapes and sizes, algebra to figure out how far and fast to move the nozzle. And then there's just different types of files that you can use. And then it also uses measurement to figure out how much material you need to use, and calculus in some advanced machines to create smooth curves. Even temperature settings and speed depend on math formulas to make sure that the specific plastic melts and cools at just the right temperature. And lastly, here's the conclusion. So this is just a very short summary of kind of the things that I learned while researching about 3D printers. So You build objects one layer at a time, but it's melting materials, and then it starts from a computer instruction. It's different from traditional methods. It's better for custom designs, small batches, and less waste, which is nice for our environment. Math makes it work using geometry, coordinates, and measurements to print precise shapes. And lastly, 3D printing is always evolving, now used in medicine, fashion, food, and even in space technology. Here are my references, and thank you for listening.